Hey everybody, this video is to help you out with your evaluating and domain homework. So we're going to start off with some square roots here. Let's say we take the square root of 25. You guys would be able to tell me that that is 5. The square root of 16 is 4, and the square root of 100 is 10. But like we talked about a little bit before we left, those are just called the principal square roots. That's just the positive version of that. If I take the square root of 25, let me grab a different color here. If I take the square root of 25, I would also be able to get a negative 5. If I took the square root of 16, I would also be able to get a negative 4. And if I took the square root of 100, I would also get a negative 10. Those are called the negative square roots. So we always have two square roots whenever we take a square root. Because 5 squared is 25, as is negative 5 squared. 4 squared is 16, negative 4 squared is also 16. 10 squared is 100, and negative 10 squared is also 100. So a square root always has two answers, so would a fourth root or a sixth root. The principal, which basically just means positive, and the negative version of it, which is just called the negative. The location of a negative in a root is very important. So if we had the square root of 25, you would just tell me it's 5 or negative 5. The principal square root of this, though, if we follow the order of operations, we would first do the parentheses, which there's none of those there. The root counts as an exponent, so I would do that. The square root of 25 is 5. And then I would do the negative under the multiplication step to get a negative 5. So if that negative is outside, you do the square root, and then you can just take the negative of that answer. If the negative is inside, though, if we took the square root of the negative 25, we would do parentheses first, so we would do the negative 25 first, try to take the square root of that, which you can't. It's not a real number. So on some of the questions, it'll just have you say it's not a real number. But like we talked about, and I think later on in this section, there are imaginary numbers. So you would say the principal square root of this is 5i, and the negative square root is negative 5i. So just watch where that negative is. If the negative is outside, you would do it just like normal, but make the answer negative. If the negative is inside, then you have those imaginaries. Okay, so kind of along with that, we're going to talk about some terms for parts of these roots. So let's take that negative square root of 25 again. That symbol there, that root symbol, is called a radical. So you'll also hear these called radicals. Radicals and roots are kind of the same thing. So the radical is the name of the symbol. The stuff underneath the radical, that 25 in this case, is called the radicand. That's what you're taking the root of. And then there's also a little tiny number, in this case it's imaginary, up in the radical there, called the index. The index in this case would be 2, because it's a square root. If there's nothing there, you assume it's a 2. Anything else out front, like that negative, or let's say there's a 4 there, that's just called any sort of constant that you're multiplying by there. So let's look at another example there. Let's say we had the cubed root of 37. The 37 would be the radicand. The 3 would be the index. And it would be shown in this case. If the index is 2, you can assume that it's a square root and you don't have to put it there. But any other situation, you would have a number in your index. Okay, so that is it for roots. Now we're going to move on to function notation, and then we'll go into how that helps us with finding domain. So let's say we had f of x equals x plus 2. So first off, I want to point out that f of x is not multiplication. That's not f times x, that is f of x. So it's just another way to write things. This is essentially saying y equals x plus 2. The reason we use function notation is because it allows us to evaluate. So maybe you'll see something like f of 3 equals what? They replaced x with 3, so you do the same. So you would say f of 3 equals 3 plus 2. Or in other words, f of 3 equals 5. So that tells you put in a 3, you get out of 5. We'll take another example here quick. Let's say it asks you for f of, oh, sorry, let me back up a sec. Let's say it asks you for f of negative 7. You do the same thing. You'd say f of negative 7 equals negative 7 plus 2. And f of negative 7 equals negative 5. The really nice thing about function notation, and pretty much the reason we use function notation, is it gives you a coordinate. So f of 3 equals 5 would tell me 3, 5. F of 7 equals negative 5 would tell me negative 7, negative 5. And that's my two sets of coordinates. It shows you your input and your output right together. Okay, so now let's look at how that helps us out with domain. So let's say we had f of x equals the square root of x plus 2. There's a couple different ways you could figure out what the domain is of that there. One way that you could do so, the first way that I would do, is with a graph. So I'll show you how to type that into Desmos here. So there's a couple ways. Down in the bottom left, there is a square root symbol. You can just tap on that. Or if you're on a keyboard on your computer, you can type SQRT, and it'll give you that symbol right there. And then you type in your function, x plus 2. If we're looking for domain, we're looking for x values. So if I look along here, looks like the lowest x value I can get is negative 2, and then I go all the way up forever and ever the other way. Later on we'll talk range, but for right now we're just going to focus on that domain. So what x value can I put in? Looks like negative 2 and higher. So there's a few different ways that you can write that. I'm going to look on MathXL quick and see which way they want it. And then I'm not going to edit this out of the video. So you're going to just sit here awkwardly for a sec, because there's a whole bunch of different ways you can write this. Okay, found it. So they wrote it as in set notation, so that would be x such that x is greater than negative 2, because we said it was negative 2 or more. Like I said, there's other ways you could write that. If you said negative 2 or more to someone, they would know. Computer, though, is going to be particular. So let's look at how you can figure that out algebraically. So you ask yourself, what's the smallest thing you can take the square root of, which is the square root of 0? So that says we want that inside part to be equal to 0. And then you solve that, and you get negative 2. But then we said more than 0 would give us a square root that works. So we need to change that to more than negative 2 in our solution there. Sorry. Let's see if this is still going. Okay. So that's how you solve that algebraically. Let's look at one more example here. Let's say we had the cubed root of negative 27x. So first off, I'm going to graph that. The way you'll do that is you'll go and do functions over here on the bottom right. And then if you click on miscellaneous there, there's that nth root right there. If you click on that, it'll give you an index. You put in 3, and then you can just type in your function right there, negative 27x. And if you look at that one, we zoom out, it goes on left and right forever and ever and ever. Forever and ever. Does not stop. So there's a few different ways you could write this. One is x such that negative infinity is less than x is less than infinity. Forgot a symbol there, oops. So basically any number, which is the next way you could write it, x such that x is a real number. Or you'll also hear it just as x is any number. Technically, it does have to be a real number, but in most cases, imaginary numbers are kind of assumed not to be real. So let's kind of look at that one and look at why that domain is a little different. And we're going to take the cubed root of negative 27. On this one, with an odd index, or a cubed root, or a fifth root, or a seventh root, anything like that, you can take the cube root of a negative, because negative 3 times negative 3 times negative 3 is negative 27. Negative times a negative is a positive, times another negative is a negative. So you can get out that negative if you have a negative root. So odd roots, you can have negative. If you have those even roots, then you have to say that's where you end up with those not real solutions. But with an odd, you'll always be able to get a real solution. Okay, and I think that's it for that homework. I hope that helps. If you have questions or concerns or anything, send me a remind message, or send me an email, or whatever. I'll set up a Zoom later on this week as well. You can stop into that. Good luck.